So in the last lesson, we looked at the structure of an atom, and in the last lesson, when we looked at the structure of an atom, we said that an atom is supposed to have these things. It's supposed to have a nucleus, and within a nucleus, there are protons and there are what? Neutrons. And then after that, we have what? A shell, and within the shell, we have what? Electrons. Is that okay? So we're saying there we have what? Electrons, and then we have the protons, so now in this lesson we want to talk about electronic configuration, so when we look at electronic configuration, the main part yatinoda tinyanyobata are these electrons, so in other words, we are saying electronic, we look at what? Electrons. Then configuration, we look at what? Arrangement. Sorry for that. So in other words, we are saying electronic configuration can be defined as what? As an arrangement of electrons in an atom. So our question ikauya yakanzi define the term electronic configuration, unotaura kuti it is the arrangement of electrons within the shells of an atom. Are we together? So for example, tine sodium, sodium yedu, if you try to look at the periodic table, you have something like this. You have 23 and you have 11 like this. And so kana tine pa periodic table yedu tine something like this, and we are saying kuti isusu tikuda kutora this because this is the number of protons which is equal to the number of what? Electrons. And saka since it is equal to the number of electrons, ndakuti these electrons angu they are 11, so ari 11 ndakuda kuona manje kuti achaarrangewa sei mukati umu, saka as you can see we have 1 2 3, then we have 3 4 5 6 7 8 9 10 and 11, so in other words, sodium yangu here in 11 my electrons, but these 11 electrons, see, they are distributed within this how many shells? 1 2 and 3, and then akabva arranged, but kuti arranged kudaro, there is a rule inoshanda ipapo, saka you just don't arrange them ngoti inini ndikufunga kuti nhasi regai ndimboisa mamwe ma-electrons kunze uku kundomaisa akawanda, then emukati ndomaisa ari mashoma, kana kuti emukati nhasi ndoda kumbomaisa ari 8, then kunze uku ndozongona kutamba. Hazviitwe zvakadaro. There is supposed to be a rule. This rule will govern you kana wakuta sei? Kana wakuta arrangement yechi yema-electrons ako ese aunenge uchiita within the shell. But in this first slide tikuti isusu the main thing chatokufana kunzwisisa kuti chiri primarily important is electronic configuration is the arrangement of electrons. It's the arrangement of electrons, kurongedzwa kwema-electrons within ma-shells. Saka each and every shell rine mutemo waro kuti umu munorongedzwa zvakadi, umu munorongedzwa zvakadi, umu munorongedzwa zvakadi. So let's look at that. So electronic shells and configuration. First point yedu ndeyekuti iyo shells are filled from the innermost, n is equals to 1 outward. So tikureva kuti from the innermost achinoenda kune ari outward, sa innermost redu rindoranzi it's what? N what? 1. Tomboti iri 1 tritesed. Are we together? Then 1 iri rikapera kufiliwa razara tobva tafila number 2. Are we together? Then after number 2 yazara tochibva tazofila number 3. Are we together? Saka rule yedu irikuda kutiedza kuti taurira kuti shells are filled from the innermost. From the innermost rikazara, then tobva taisa rinotevera rachona. Rikazarawo tobva taisa rinotevera kusvika ma-electrons edu apera. Saka second point, maximum electrons per shell ndo rule yedu iyi yatachitaura tritese, ndo rule yedu iripo. Saka the first shell, it has a maximum electrons of 2. So our first shell redu is supposed to be filled with the maximum of how many? 2. So let's say for example we were filling ndizvo toti first shell redu toriti 1 toriti 2. Kana raita 1 2 ratozara handiti. Then kana pane mamwe ma-electrons asara, second shell it is filled to a maximum of 8 electrons. So 8 electrons atiri kutaura 8 ma-electrons ari mu-second what? Shell. Tritese. Saka takuti mu-second shell takuti 1, 2, then 23, 24, tobva tati 5, 26, tobva tati 7, tobva tati 8. Mind you, uona kuti 8 aya ari muchi? Ari mu-second shell. Kwete kuti taedha m-first shell ne-second shell. Tiri kuti ari mu-second shell there must be what? 8 kuti ave maximum. Ari mu-first shell there must be 2 kuti ave maximum. Then tobva taenda pane third shell. Saka third shell redu rine a maximum of what? 8 electrons. Saka torowachi 8 ma-electrons edu aya. 1, 2, 3, 4, 5, 6, 7, 8. Then abva atata sei? Akwana. Obva aita chi? 8. Saka imimi for your level you only look for the first 20 elements. And it so you find out mune mamwe ma-textbook pane zvinhu zvinokwanisa kusiyana ndizvo zve. But imimi for you the curriculum yenyu or the syllabus yenyu it only states kuti you are supposed to know for the first 20 elements. And for the first 20 elements those are the rules that what? That govern. And it saka isusu kana tichiti pane 2 ma-electrons we are saying what? It's duplet. And it kana tichiti pane 8 ma-electrons we are saying it's what? Octet. And it saka you find out it's a duplet rule, it's an octet rule. And it so let's go to the next. So an example yedu yatinayo we have the sodium. And it sodium redu can be written like this. Sodium redu ra drawiwa rakadai. Handitika sodium pekuta rine 11. Saka we are coming from this apa takodzokorodza edu. So we are saying sodium and then 23 and then 11. The number ya true cautious is what? 11 and 23. Atina basa naye is just the mass. And here we are looking at the number of electrons. Don't make that mistake yekuti unotora 23 wakuchimisa. 23 uyo ari pane sodium apapo ndewe mass haaswe ma number of electrons. So katisiyane naye. Let us leave this 23. Timude treatise. Saka takuchiti takumafila tutanga tafila ekutanga 2 ndizvo zve. Then tobva taita the 8 echi at the second. Then taita the 8 at the second tobva tazoita 1 rinenge raita se rasara. But how are we going to do it ndizvo zve? There is a written way or a written structure ino yatinayo yanditi. Saka tiri kuti chii? Tiri kuti isusu rega timbotanga takadai tikuti tine 11 electrons ndizvo zve. Tine 11 electrons tichatanga tafila 2 mekutanga. Handiti tafila 2 mekutanga tobva tati toita kakoma kedu kakadai. Then tobva tafila chi 8 toisa kakoma. Saka tichabva tati 2 plus 8 inotipa chi 10. But isusu tine 11 ma electrons. Saka takuti 10 minus 10 from 11 panosara chi 1. Tobva taona kuti chi 1 ndo rabva raita sei? Rabva rasara. So therefore electronic configuration yedu inenge yakadai so. From yakadai so you are able to draw uchitoziva kuti 2 ekutanga ndewe mukati wakutoziva kuti pa ndizvo zve. Obva wati 8 dzinotevera idzi obva watorwa 1 2 3 4 5 6 7 what 8. Then obva watire chi 3 ro rinenge rine chi rinenge rine 1 obva watoti chi 1 obva watorwa chi sodium yako. Then let's try to draw the electronic configurations using ma details atinowana from the periodic table. Saka apa tine magnesium yedu. Saka first of all we identify this is the mass, we don't want it, and what we want is this one 12, which is the number of what? Electrons. And so panapa we have what? Number of electrons yedu, it's equal to what? 12 electrons. Ndizvo zve. saka aita 12 electrons yedu ndo atakushanda nawo. Takuchibva tati the first 2 handiti, after the first 2 tobva taisa 8 mamwe, titeze taisa 8 mamwe tikati 2 plus 8 panosara chi, panoita 10, then 10 from 12 pachasara chi 2, saka inobva yaita chi 2 like this. And so panapa we now have an electronic configuration which is written, and then takuchidraw takuti 1 2 for the first, then tobva tati the second yedu ine 1 2 3 4 5 6 7 8, then we have the third one redu rinenge rasarwa ne 1 2. Is that okay? Then toenda pane nitrogen yedu. Nitrogen yedu ine 7 electrons, saka we have 7 electrons. Saka nitrogen yedu tichatanga tati 2 yekutanga, saka tikati 2 yekutanga from 7 pachasara ngani 5, saka inenge yakadai. So saka its electronic configuration is like this. Takuti 2 ekutanga 1 2, then tobva taita the second shell redu rine 5, 1 2 3 4, and then we have 5. Saka this one is for what? Is for nitrogen, and this one is for what? Magnesium, Mg. Then after that, now tanga tichitarisa nezve issue ye-arrangement yema-electrons ndizvo. And when we talked about the arrangement of electrons, tanga tichinyanyo specialize primarily on how they are arranged and the rule yatinoshandisa yekuti first shell is 2, second shell 8, and then third shell rine maximum of what? 8 again. And now we want to look at valence electrons and metals and non-metals. Are we together? So valence electrons is equal to the number of electrons in the outermost shell. Are we together? That is valence. You will later on find out a word rinonzi valency. Totese. Iri word iri rakatosiyana ne word rakanzi chi valence. These ones are totally two different things. So you have to take note. Usazongoti pamwe maybe it's another spelling. No, zvinhu two zvakaita sei zvakasiyana, but they are closely related. Saka tikuti isusu ma valence electrons is equal to the electrons in the outermost shell. Are we together? Saka mu outermost shell medu, let's say tatadzokera kuno kwanditi umumu nitrogen yedu ine 5 my electrons, 1 2 3 4 5 my outermost shell. So its valence is what? 5, the number of electrons in the outermost shell. Ndiyo 5e yaunoona iyi kokupedzisira. Then also magnesium ndo 2 yaunoona kokupedzisira, ine 2 shells in the outermost shell. Then to determine this valence yedu, it helps us that we determine what? The chemical behavior. Yatiri kuti chemical behavior iyi ndoda kuti ugare waziva nditika chinhu chatoti chemical behavior of an atom, we are trying to describe how it reacts. And it so how it reacts, chinhu chakanyanyokosha is that when you look at an atom and how it reacts is fundamentally based on the issue of the behavior yema electrons. And it are we together? So these electrons edu kuti ave ne behavior yangori ne two behaviors, is either they are given out to saka it's either they are lost or given out, or the atom will gain what? Electrons. And so this behavior yekuti ma electrons anoluzwa then anokwanisa kugainwa ndizvo ndo yatinodefine as a chemical behavior. Because chatiri kuti chemical behavior wachona chemistry wachona huri pama electrons mashiftiro anoita from one atom to the other, or kuti ma electrons awo ari kushare between what? Ma atoms. And ndiyo issue iripo yese yatinenge tichiti chemical reaction titese. That's why you find out kuti kune word rinoshandiswa rinonzi chi bonding. Let's say for example musikana ane bond nemukomana titese, they have something that they will share in common titese. But pane something chino share in common ipapo, let's say kuti mukomana anoda musikana, then achida musikana anogara achita se achimupa magifts nyangwe musikana asingade mukomana, but the fact yekuti ari kureceive magifts ndizvozve mukomana achaita tend kuti achadevelopa an affinity or achadevelopa a bond nemusikana tritese. Saka you see that the behavior yakada kudaro is the same behavior that we are finding in what? In ma-atoms edu. So ma-atoms edu, if they portray a chemical behavior, anything chauchanzwa kumberi kuchinzi chemical behavior, chemical reaction, they are trying to tell you about the movement of electrons. Kuti acha give away here, acha torwa here, kana kuti vacha share. Is that okay? Then the first 20 elements, we have the rule for the first 20 elements in that their chemical behavior. So ane valence or anema outermost electrons from 1 to 3, they are regarded as metals. Are we together? Metal tukurea kuti ndo varume ava. There's a men, they give out what? Electrons. They give. Those electrons are able to be given out. That's why they are called metals. And then from 4 going onwards, anonzi machi non-metals. But tiri pama non-metals ipapo, we primarily look at these 3, which is 5, 6, and 7. Saka 5, 6, and 7 edu they receive electrons. Vaskanava, they receive. In other words, you have to they receive, and they take in, they receive. Mabeba. Saka katichi gareta ngozviziya musoro medu kuti a metal is the guy that is giving. The non-metal is the girl that is what? That is receiving. But you later on find that the analogy will become the same. Muskana ne muskana, they share a lot of things. You find out kuti bond re muskana ne muskana, vaskana they tend to have bond steric. Varume, they just don't have my bonds. Zvekuti anongosangana nemunhu, asangana nemunhu, iye wasangana naye that day. Later on, chibaba, but atokanganwa, have formed that bond that strong. That's why you find a lot of men, they don't have much friends. But when you look at females, they have much friends because there's something that they are sharing. They are sharing, maybe I'll share to Namuto Amino. I don't know. But the idea is that on reactions happening, there is something being given, there is something being received, and there is something probably being shared. For example, sodium yedu, if you look at its electronic structure or its arrangement, you find out in a 281. One wedu uyu representing the what? The valence electron. Saka if 1 represents the valence electron is between 1 and 3, so it will become a metal. Saka you can identify just from the electronic structure that this is a metal. Then again, chlorine yedu in a 2, then a 8, na 7. 7 being the what? The number of the outermost electrons or the valence electrons. Saka 7, it goes under a non-metal, so it will be a non-metal. So pekutanga, you've now gained a picture of what's really happening. And so it is very important, especially at the introduction, it's very important to understand the role of electrons. Electrons will participate in what? The reactions. Reactions happening, electrons will participate. Then they would get influenced by what? By my protons. Are we together? You will look at that. They will get influenced by protons. They will also get influenced sometimes by neutrons. Saka, let's look at what we call the stable electronic structures. Are we together? We are saying stable. Stable means it's chinhu chaka, it's stable, it's not changing, and it stable electronic structures. So we are saying that the electrons, they have been arranged in certain structure that make them stable, and it saka stable meaning kuti haichaite any funny what movements. And also we have what we call noble gases. Noble gases, these guys, they are noble. You know, these guys, they don't react. They are just cool like that. They don't react with others. Vanenge vatongori noble like that. So the first point to vatanzi is also atoms are the most stable when their outer shell is full. Are we together? Now we're saying when the outer shell is full, that's when it's what? It's stable. Okay, let's try to go back to these guys. Let's go back to these guys. And what do you think? This one, we ans magnesium treatise. And how many electrons? I need 2, and it just use another color. I need 2, my electrons are in my outermost shell. But I need 2 kudaro. 2 iwa has 8. So as 8, it's not stable. As full. This one need 2, 3, 5. 5 are, they are not 8. As full. So now, as full kudaro, it therefore means that the structure is not stable until it has to gain an electron or it has to lose an electron, such that it becomes what? Stable. And it so kuti tione stability yema electrons edu, we also have the rules. And it these rules ndizvo anonzi ndo configurations or structures. And it saka this rule yedu, we have first, we have what we call the duplet configuration. And we also have what we call the octet configuration. So octet configuration, that's the octet rule. It means oct from octagon. Oct is supposed to have what? 8 electrons. 8. So we are saying that mune second shell muno medu ukatarisisa 8 wedu ari mu second shell because we said this one is the first and this one is the what? Second. And now this one really the second shell, it has to have a maximum of what? 8 electrons. And then the third shell, it also has to have a maximum of what? 8 electrons. That's the octet configuration or the octet rule. So kana asvika ipapapa, they are innate or unreactive and exist as what? Single atoms. And it saka that's the only thing chinenge chichitika ipapa triteseri. Saka most of the noble gases edu, they are like that. Ukaenda iwo ukanonotarisa pa group number 8 or group number 0, you find you have helium triteseri. White helium, you also have nana neon, and you also have what? Argon. Saka uchibva pane helium, neon, argon, they all share the common trait ye group 0 or group what? 8. And are we together? The group 0 or group 8 rukunzi ndorine ma noble gases. These have what? Ma configurations are stable. Are we together? Then from this, you would have to look at your revision. Then work on the revision yako, unyore my electronic structures, etc. Then on this one, you have to draw the diagram. So you have to draw the diagram ma-electronic structures or electronic configuration yako diagram tokuti hameno zvaunodrowa, then you put out the atom, the electrons kuti akaarrangewa sei. Then for that one, and then for this one you're comparing up, but this one now the tip is that you are now using what? You're now using my electronic structures, but these electronic structures are written form. So mind you, you are primarily looking at what? At the last value, and it so which means when you finish this, our next lesson will be looking at what? At isotopes. And